Here we're finding the greatest common factor for monomials. And so here we have more than just a numerical expression, right? More than just an integer. We have a variable expression sometimes included. And so we do the same thing. So if we look at number 24, we could write 12x squared in terms of its prime factorization, right? So 12 breaks down to 2 times 6 and 2 times 3. So we can write 12 as 2 times 2 times 3. And then the x squared we can just write as x times x, right? We can just expand it. We can do the same thing with 4x cubed. We can write that as 4 is 2 times 2, so we can write that as 2 times 2 times x times x times x, right? So now we can see what they have in common. They each have a pair of 2's in common, and they each have 2 x's in common, right? And so we can multiply these together, 2 times 2 times x times x. So we multiply those prime factors in common and we get 4x squared. Okay? All right, so you might notice that basically what happens is when you deal with variables, they're actually pretty simple. If you have the same variable in common with all the terms that you're finding the greatest common factor for, you take the one with the smallest exponent, right? Because there can't be more than 2 x's that go into x squared, right? So that's the most you can have in common, the greatest common factor, right? Okay, so let's take a look at 26. So they all have a y in common, so I would take the one with the smallest exponent. So I know it's going to be something y cubed, okay? Because if I listed out all the y's, I'd have 5 y's here, 4 y's here, 3 y's here. The most they could have in common is 3, right? Okay, so y cubed is going to be there. And then with the 3, the 9, the 15, one thing you can do sometimes is just look at the smallest number. So the only number that goes into 3 is itself, right? Because it's a prime number. And 3 does go into 9, right? 3 goes into 9. And 3 does go into 15. So that means 3 is the biggest number, the biggest integer that can go into 3, 9, and 15. And so that's my greatest common factor is 3y cubed. All right, so sometimes you might have to do a factor tree or list it out in prime factorization. Sometimes you might be able to do it without showing the work. And so it just depends on the situation, the problem, and your comfort level. All right, let's take a look at number 30. Okay, so number 30, so I'm going to do the prime factorization for 30 and 75. So 30 is 3 times 10, 10 is 2 times 5. 75 is 5 times 15. 75 divided by 5 is 15, and 15 is 3 times 5. So what they have in common is they each have a 3 and they each have a 5, right? And so 3 times 5 is 15. So 15 is the numerical greatest common factor. Then with the variables, I'm going to see what they have in common. They each have an x. So I'm going to pick the one with the smallest exponent. So it's going to be x squared. They each have a y. And they're both to the first power, right? So I'm going to pick the one with the smallest exponent, which is y to the first. So that's just y, right? And then with the z's, they have z's in common. So I'm going to pick the one with the smallest exponent. So that's z cubed. So there's my greatest common factor is 15x squared y z cubed. All right, so let's take a look at 34. So 34, we have 3 terms, or 3 monomials here. And so I'm going to deal with the numbers first. So 16 is 4 times 4. Each 4 is a pair of 2. So 40 is 4 times 10, right? 4 is 2 times 2. 10 is 2 times 5. And 72 is 2 times 36. 36 is 6 times 6. 2 times 3. 2 times 3. Okay? So then what they have in common, they each have a 2. They each have another 2. All right, and that's it, right? No more 2's with 72, so we can't use this 2 here that we have with 40, right? And 16. So 2 2's of what they all have, all 3 have in common, so that makes 4. 2 times 2 is 4. So let's see what variables they have in common. Do they all have an x? No, this one doesn't have an x, right? So we don't include any x's. Do they all have a z? Yeah, they do all have a z. Z to the first is the smallest exponent, so we're just going to write 4z to the first, or just 4z. All right, so that's the greatest common factor there. So if they don't all share a variable, you're not going to include that particular variable, right? Because it's not common with all the terms.